All right, so we are going to rearrange the equation to solve for y. So remember up here back in equation number 1, we had x plus y equals 20. And when it says solve for y, remember that means get y by itself. So solving for a variable means to get that variable by itself and get everything over the other side of the equation and simplify as much as you can. So our equation was x plus y equals 20. So if we are solving for y, we're going to undo the x from the left side of the equation. Since it's a positive x, we will undo it by subtracting. X minus x is 0. And that means on the other side of the equation, we have 20 minus x. Since those are not like terms, we will just keep them separate. So you can write it like that. Or another way of writing this is you could put the x first if you really wanted into y equals mx plus b form, slope-intercept form. You could put that negative x first and then the positive 20, because the minus sign is in front of the x, we would want to keep that there. So either one of those could work. All right. So what we'll notice from this equation, now you may be used to seeing an equation a little bit more like this. So it is a linear equation. So the question is, what connections, if any, do you notice between your equation and the graph? It is a linear equation in slope-intercept form. In other words, y equals mx plus b form, with a slope, which remember is the m of that. The slope is -1. Remember, this number in front of the x is the slope. So the slope is -1. And y-intercept, which remember is the b of the y equals mx plus b, of 20. All right, so notice our graph up top there does have a y-intercept of 20, and it does have a slope of -1. So if we put it in that form, we should see that it matches up with the graph, even though the equation has been rearranged. All right, let's go down to the second equation. What's the number of rides the student could get on if they don't play any games on the coordinate plane? Mark the point that represents the situation and label the point with its coordinates. So we have the same sort of question as we did on the previous problem, just with a little bit different equation, 2x plus 4y equals 28. All right, so what we're asking here, if they don't play any games, that means that the x value is 0. All right, because the games are on the x-axis. So if they don't play any games, that means the x value is 0. So we got to do a little bit of solving here. So if we put 0 in for x, I'm going to do over here. So 2 times 0 plus 4y equals 28. And then let's figure out how many rides that would be then. So 2 times 0 is 0. So you really have 4y equals 28. And then dividing by 4. To undo the multiplication, we get y is equal to 7. So if the x value is 0, then the y value becomes 7. So 7 rides right here. All right, so let's label the point. So 0, 7 then would be right there between the 6 and the 8. So 0, 7. And again, that means that we have 0 games and 7 rides for that problem. Okay, and then the reverse of that is what we see in the next one. What's the number of games a student can play if they don't get any rides on the coordinate plane? Mark the point that represents the situation and label the point with its coordinates. So if they don't get on any rides, that means that the y value is 0. Like we did in the first problem, that means that we got to put 0 in for y and then work backwards and figure out what that matches up with for games. So I'm going to do that over on the side here. So that means 2x plus 4 times 0 equals 28. Let's go ahead and solve. 4 times 0 is 0, so that really means 2x equals 28. Undo multiplication by dividing. So that means x is equal to 14. So if the y value was 0, if they didn't have any rides, that means that we must have 14 games. All right, so 14, 0 would be that point right there. 14, 0, so 14 games and 0 rides. Just like in the first problem, let's go ahead and draw a line to connect the points that we have drawn in there. All right, looks good. And then let's go ahead and complete the sentence. If the student played no games, then they can get on 7 rides. Remember, that was our number up here. That is our y-intercept, 0 games, 7 rides. For every additional game after that, though, the student plays, the possible number of rides once again decreases. And maybe you can kind of see how much it's decreasing by on that one. If not, if you look up here, every time we go up 1 game, then how much is that number of rides going down? If we look very carefully at the rise over run here, so if we look at the rise and run amount, we are going for a run, we went over 14, and then we went down 7. All right, so let's think of that as a -7 rise. So we went to the right 14 and down 7. So the slope of our graph as a rise over run, if we take those 2 points, that would be -7 as our rise and +14 as our run. So that would be -1/2 if we want to do it as a decimal, -0.5. So for each additional game that the student plays x, the possible number of rides decreases by 1/2. All right, let's rearrange the equation and solve for y. So remember, when we are solving for y, that means get y by itself. So our equation was 2x plus 4y equals 28. Y by itself. All right, so let's do some solving steps. If we're trying to get y by itself, that means we start by moving the x. We start by adding or subtracting and move the x over to the other side. In this case, it's a positive 2x. So to undo it, we would subtract 2x over to the right side, bring down what's left. Remember, these are not like terms on the right side of the equation. One has a variable x and one doesn't, so we keep them separate, 28 minus 2x. And then we have one more step because we still need to get y by itself, so we have to undo multiplying by dividing both sides by 4. And when we do that, we could leave the equation like this, 28 minus 2x all over 4. Oftentimes, though, it's better to reduce the fractions. So 28 divided by 4 is 7. And then we also have to take -2 divided by 4. So -2/4 is the same thing as a -1/2. So 7 minus 1/2 x is probably the best way to write that when we are solving for y. So now it's in that y equals mx plus b form. So once again, we can notice that. So it is a linear equation in the form y equals mx plus b. So in other words, slope-intercept form. The slope is -1/2. Remember, that's the number with the x, even though it's the second part of that equation there. All right, that's the m value. And y-intercept is positive 7. Remember, that's our b value. And we notice up in the graph that that was the case, right? We had a y-intercept here of positive 7, and we did have a slope on our graph of negative 1/2.